So the word determinant is not something new to us. We used it when we worked with quadratics. If you recall, b squared minus 4ac simply gave us a little bit of information about what was the behavior, what was going on with a quadratic. It told us how many roots there were. And the determinant for a matrix, likewise, just gives us a little bit of information and tells us a little bit about that matrix. And the important thing that we're looking for right now is whether or not a matrix has an inverse. So the rule is that if the determinant equals 0, then there is no inverse. And we call that matrix singular. So a matrix is considered to be singular if there is no inverse. And we know that there is no inverse if the determinant is 0. And if the determinant is not 0, so if it's not equal to 0, then an inverse exists. So an inverse does exist as long as the determinant is not 0. So the determinant is just a number. It's just going to either be a positive number, a negative number, or 0. And right now we're not really concerned with whether or not that number is positive or negative. We're really just looking to find if it does equal 0. And the notation that we're going to use, and your calculator uses this, so we're going to call it, like if we call this matrix A, the notation you're going to see is determinant A, and the determinant is a function in your matrix menu on your calculator, and it's called, actually I think it puts it in parentheses, it says determinant of matrix A. And then the other notation that you're going to see, oops, I want to erase that. Actually, I'll just cross that out. The other notation you're going to see, it looks like an absolute value sign. So the absolute value, it's not the absolute value when we're talking about matrices, but if you see an absolute value sign with A, that is simply asking for the determinant of A, okay? So both of these notations are notations you need to be familiar with. It's either just DET or it kind of looks like absolute value signs, okay? So this is how to find it, and I apologize. It's just a pattern that you're just going to have to memorize. The way that we find the determinant is we multiply on the two diagonals and we subtract them. So for a 2 by 2, it's pretty simple. I'm just going to do this diagonal times this diagonal. And what that looks like if I write it out is I'm going to have 2 times 1 minus, and we're going to subtract those, 4 times 3. So we have 2 minus 12 is negative 10. So the determinant of A, and the notation for that would look like this. It would say the determinant of A, or I could have the determinant of A with that other symbol that I told you about, equals negative 10. Okay? Now for a 3 by 3, so a 2 by 2 is pretty easy, but a 3 by 3 is a little more complicated because I basically am going to have to come up with 3 different diagonals. And the first diagonal is pretty easy, but this one falls short because there's no number here, and then I have to continue down this diagonal, and this is missing 2 numbers. So what we're going to do is we're just going to simply repeat columns 1 and columns 2. So negative 1 and 0, and 1 and 2. So all I did was I repeated these first 2 columns at the end. I just tagged them onto the end because now what I'm going to do is I'm going to multiply straight down. So this diagonal, and this diagonal, and I'm going to add them all together. And then I'm going to going the other way, I'm going to go the upwards diagonal. So I'm going to go this diagonal, and this diagonal. And again, I'm going to add them all together. And then in between, I'm going to subtract them just like I did up here. Okay? So let's do that out and see what that looks like. So I'm going to have, and I'm not going to write them all out, we're just going to talk about this. So what I'm going to have is 1 times 0 times 0 is just the number 0. So that's my first diagonal. So I have 0 plus, remember I'm going to add them, all 3 going downwards first. So that was 0. This diagonal here becomes 2 times negative 3 times 1, which is negative 6. So I'm going to add negative 6. And then the last diagonal is down here, so 3 times negative 1 times 2, again, is negative 6. So I'm going to add to that negative 6. And altogether, that equals negative 12. So now I want to subtract, and I'm going to subtract the diagonals going upwards. Okay? So, oops, sorry, didn't mean to do that. So this first diagonal is 0. Can you see that? 1 times 0 times 3. I love zeros because they're always 0. So that's just going to be 0. The next diagonal is right here, so here I have 2 times negative 3 times 1 is negative 6. And remember, I'm adding in between. And the last diagonal is 0 times 1 times negative 2, which is just 0 again. So this is negative 6. So remember, I am at, ooh, sorry about that. And my undo button does not seem to be working. Oh, there we go. So what I'm going to do is I am, ooh, I didn't mean to undo so far, hold on. This is 0 and this is negative 6. So remember, I am going to add up the diagonals going down, the 3 diagonals going down. I added that up to 12. Then I'm going to subtract the sum of the 3 diagonals going up. So the 3 diagonals going up was negative 6. So remember, a minus of a negative is a plus. So this simply equals negative 6. So the determinant, if we call this, let's call this B, this is matrix B, then I would say the determinant of B equals negative 6.